Hi ladies, I just want to do a quick review and talk about vaccines and primary and secondary infections with you prior to next class. So remember that the immune system has a variety of different barriers. These barriers are really great for keeping things out. Within your body, though, if something does happen to get in, you have your innate immunity, which is nonspecific. The phagocytes here is the most important thing that you need to know. So phagocytes, those are your cell eaters. They will physically consume bacteria or pathogen or any type of pathogen that gets inside your body. The other type are those adaptive cells found in the adaptive immunity. These are specific ones. Okay, so these are your antibody-mediated B cells and your cell-mediated T cells. Remember that antibody-mediated cells, the B cells, they are going to produce the antibodies. Antibodies will go around and they will target something. They will tag something that's foreign for destruction. Cell-mediated cells, your T cells, they're going to go to the site of the infection and they can very specifically attack cells that have already been infected and kill them. So I've been talking a lot about antibodies, and I just want to kind of make this clear how this works. The reason that your adaptive immunity is so specific is because all different types of cells have different antigens on them. Okay, so antigens are proteins or carbohydrates on the surface of a virus or cell. Your cells have them, pathogens have them, viruses have them, all cells have them. They're basically like a little name tag. So if someone was to come in Ellis, okay, and they have a name tag on, you'd be like, okay, they're supposed to be here. They have the correct name tag. They're totally fine being here. But if somebody comes on and they don't have the correct identification, you kind of look at them and you're like, why is that person here? So this is the same thing inside your body, okay? All cells and anything inside your body has antigens, has these little name tags. Your B cells are able to produce these antibodies, okay? B cells will produce antibodies, and antibodies are really great because they can tag foreign antigens. Okay, something that's not supposed to be there. Okay, and this little tag is almost like a little flag, a little marker that says, hey, this isn't supposed to be here. So if a pathogen happens to come in, okay, your body produces a very specific antibody for that pathogen. You have one B cell in your body that produces that antibody. Okay, there's millions of variants. So you have one B cell that'll produce this type of antibody. You'll have another B cell that'll produce a completely different type. Okay, and the binding of an antibody to an antigen is very specific. Anytime an antibody binds to an antigen, it's targeted for destruction. Okay, your immune system knows it has to be taken away. But note here that this pathogen, okay, has this antigen, but it also has a different antigen that might have a different antibody made for it. So that's why your adaptive immunity is so specific. Okay, and note that all of these things are happening at the same time. Okay, all your non-specific defenses are happening at the same time as these very specific defenses. They all work together to try to get you healthy and safe from anything foreign that's not supposed to be there. Okay, so what happens when you come in contact with an antigen more than once? This is the next thing that I want to talk about. So if you look here on this graph, you can see what happens at the time you're exposed to the antigen first. Okay, so that could be a virus or bacteria. Remember, you're going to fight them in similar ways with your immune system. So the first exposure typically takes a while. Sometimes it can take 7 days, 14 days to actually completely eradicate and remove that foreign pathogen from your body. Note that the first time you see it, okay, this is a really slow process, okay, to figure out the correct B cells and T cells. We're measuring the amount of antibodies, so we're measuring the B cells when you find the correct one. So you have to find that correct B cell. That B cell has to multiply. That B cell has to secrete antibodies. The antibodies have to spread throughout your body. So by the time all those pathogens are tagged for destruction and finally starting to be removed, okay, It could take several days. Okay, so this is your primary immune response. Slow, steady, you have to find the correct B cell. But the second time you're exposed to the same pathogen, it has to be the exact same thing, same antigen, okay, you're going to have a much more rapid response. This is what we would call secondary immune response. And this is because your body produces memory cells. Okay, so you're going to have memory B cells, memory T cells, and these memory cells will stick around inside your body and be there for the next time you are exposed to it. So it doesn't take you all these days to find the correct B cell. You already know which B cell is the correct one. Okay, that B cell just needs to rapidly divide and produce those antibodies. And so the second time you're exposed to something, days, years, months, whatever later, you have a much more rapid response. This whole idea is utilized whenever scientists are typically designing vaccines. So I want you to pause the video right now, and I want you to watch a quick video on vaccines. It's the first one it's off the top of the haiku page, labeled vaccines. So pause your video right now, and I want you to go there. So this is the haiku page for Unit 3. Okay, here's your vaccines video. Okay, watch the entire video, and you can, during this video, what I want you to think about is how vaccines were designed and how they're taking the idea of primary and secondary immune response into effect. Okay, so you should have watched that video on vaccines. It's really interesting, the idea of using, of trying to like trick your body almost into having a primary immune response. So with something like polio, okay, Jonas Salk designed, he killed I guess you could put in quotation marks, he killed the virus using formaldehyde, and then gave that kind of weakened, killed version of the virus to people. Okay, the virus wasn't harmful, but it still kicked off their primary immune response. They had to find those correct B cells and T cells to kind of mount that immune response. And what was interesting is that if they ever were exposed to polio, the polio virus later, okay, they already knew, their body already knew how to fight it. So they would go right to this secondary immune response and have a rapid response to the virus and not develop some of those symptoms that were really terrible, like paralysis. Same thing with like the smallpox vaccine. Cowpox happened to be really similar, so the virus looks so similar that when your body was exposed to cowpox, it would fight it, and you figured out the right B cells and T cells, and it would take a while, and you got a little sick, but that virus wasn't as harmful as the smallpox virus, so you could figure out the correct cells you needed to fight, and then when you were actually exposed to smallpox, hopefully you I don't know how good it was and ethical to expose your own child to smallpox, but you theoretically, if you're exposed to smallpox, you will have this secondary immune response. It'll be much more rapid, and you won't get very sick. Okay, so let's just look at this. So acquired immunity is just resistance to an infection. So you are at the place where you'll have that secondary immune response. You can either do this actively, okay, by producing your own antibodies, or passively by getting antibodies from another source. With active, okay, this is if you actually fight it off. So say you get the flu this year and you get really sick and you have to fight off the flu, that would be naturally acquired immunity. You can also have induced. This would be vaccines right here. So you got the flu vaccine maybe instead of just kind of trying to see how it goes. Or you got the measles, mumps, and rubella vaccine or smallpox vaccine, okay? Vaccination will help you have that active immunity. What's also really interesting is you can have passive immunity either by being transferred antibodies to your body. Sometimes this is a treatment for certain diseases. You can just get antibody treatments, or this is a very common one, natural passive immunity, which is when antibodies can be transferred to the baby through a placenta or in breast milk. So this is why a lot of moms choose to breastfeed their children, because not only are they providing their child with nourishment, but they're also giving them immunity that you can't get from formula. So please bring any questions you have next class. We are going to spend a little bit of time very briefly reviewing HIV. Please make sure that you complete that packet on HIV. Okay, we're going to talk about the process of HIV infection briefly, but I want to make sure you have the background. So please complete that packet on HIV and bring that to class with you next time. Thanks, guys. Have a nice day.